Hello, and welcome to the course Networks Illustrated Principles Without Calculus. My name is Chris Britton. I'm a PhD candidate at Princeton University, and I'll be teaching this course along with my advisor, Meng Chang, Professor of Electrical Engineering at Princeton University. In this introductory lecture, I'll give an overview of what we will be covering in this course and some of the ways in which we'll go about learning the things that we will be covering. So first, you're probably wondering, what is a network? And if you look that up in a dictionary, you might come up with some complicated definition, like this. An openware fabric or structure in which cords, threads, or wires cross at regular intervals. So we have maybe some wires which are connected, and they may cross each other at different places. Or another definition, a group of interconnected, via cable and or wireless, computers and peripherals that is capable of sharing software and hardware resources between many users. So we heard many terms there. Users, like you or me, which may be connected over a wire or over some wireless interface. Now, these definitions are pretty complicated and have a lot of terms in them, so they might leave you pretty confused. So let's start with something a little simpler. How about a group of people, like you or me, or devices, like smartphones, laptops, desktops, or tablets, that are all connected in some way? Now, these connections may be over a wire, like a cable, or they may be over a wireless connection, like Wi-Fi or cellular from your cell phone. Or they may be social relationships. For instance, if you and me become friends on Facebook. This definition probably makes a lot more sense. And as we go through the course, the terms that we discussed on the left-hand side will become more obvious to you. But for right now, we'll stick to the definition that we just made. So where are networks? Well, roughly speaking, they're everywhere. For instance, we have social networks on platforms like Facebook, Twitter, and YouTube. On Facebook, we have networks in terms of friendship relationships. On Twitter, in terms of following, so who you're following or who is following you. And on YouTube, we also have networks of people, but additionally, we can draw relationships among movies, like which movies are watched by different users within a reasonable time window. Next, we have technological networks. For example, 3G, Wi-Fi, or the internet. You may run 3G on your smartphone. Wi-Fi can be run on any smartphone or any internet-connected device like your laptop. And the internet is basically the place where all of these processes are run on top of. Now, these are just 3 examples of technological networks and 3 examples of social networks. Clearly, there are many, many more, which we will look at. Now, we also have what we call economic networks, which determines how these different services are priced. So, for instance, how much you have to pay on your 3G data plan each month for the services that you use that go over the internet. So, what do you need to know for this course? Well, you may have seen a similar one that we offered on Coursera called Networks, Friends, Money, and Bytes. And in that course, we had calculus and linear algebra, or matrices, listed as the prerequisites. And we may have written an equation that looked something like this. Pi of t equals gamma I over SIR I of t times Pi of t minus 1. So in this equation, we have subscripts, like i's. We have variables, like this power over here, or this SIR, and we have an index of time, which appears in some of these. And while this is mathematically convenient to write down, it doesn't help the fact that there's a lot going on and this looks pretty confusing. So we thought a lot about whether we can offer something similar without the heavy mathematical prerequisites, and that's what led us here. So in this course, there's really only one prerequisite, chalkboard math, if you will, adding, multiplying, subtracting, and dividing. So we will write this equation in the first lecture as next power equals what's called the ratio times the current power. So rather than having to sit through the mathematical notation, we can write this in a much more convenient form, which includes just a multiplication. And that should make a lot more sense to you. Now, how are we going to present these lectures? We thought a lot about the pedagogy, or the teaching style, that would be the best for this type of material. We summarize that in 3 A's. The first one is analogies. Networks lend themselves very well to analogies to systems like transportation networks or the postal service. For instance, we can relate congestion on the internet to what happens when you sit in a traffic jam. And we can see how pieces of data get through the internet by looking at how messages are routed in the postal system. So we'll call the first A here analogies. The second one is historical anecdotes. Sometimes the best way to understand technologies is to look back to how they were invented in the first place. So we can call this anecdotes. The third one is animations. You've probably heard the phrase that a picture is worth 1,000 words, and indeed, networks are no exception to that. So we'll be using a lot of pictures to explain the material. We can call this animations. Now, each of these lectures revolves around a few key principles. Namely, we have 8 of them, which we call 8P. These principles are simple phrases that could probably fit within these 2 quotation marks right here. So they're about 3 or 4 words each. They summarize a vast amount of networking ideas. And we'll go through some of these principles. Specifically, we'll go through 5 out of the 8 of them. The reason we won't go through all 8 is because we only have 6 weeks together, but we'll do as much as we can. Now the question is, what are these principles? So let's briefly go through them.